What's up? I'm set up here, back from the dead. Rust programming, Arms Club. Let's get some links. Check it out. Join the Groms Club NFT group community, the Grom community. Join us. So I'm sorry, folks. I'm gonna be a little rusty. No pun intended, I suppose. Getting back on the coding stream chain. I've been missing this, and I'm excited to get back. Let me get my IDE up here. Make sure we got the right things going. I know we just got a blank screen. So we want our hello world, huh? Let's bring my screen up. Let's bring it up. We want screen 2. Let me get that out of the way. Let's get our IDE in the way. Just a second. We got some. We got some trying to happen. We're not going to worry about that right now. All right, don't worry about that. So, all right, we got one on the stream. Welcome. Yeah, how's it been going? Welcome. Let's see what's going on. We got someone in Discord popping off. Yep. Man, it's gonna take me a minute, to get back in the groove. But I tell you, I'm ready. I have been missing this. Where have I been? Been busy. It's been a busy beginning of the year. Good beginning of the year, but very extremely busy. I'm still busy with stuff I won't go into. But man, I've really been missing this. I'm gonna do my best to get this back out once a week. We'll be doing coding, Rust coding. We'll be doing Solana coding. All that on-chain fun stuff. I've been messing around a little bit with some TypeScript, to be honest, when I've had a spare moment or two. So maybe we'll do some TypeScript. That's real, like, in the Solana ecosystem, TypeScript's like kind of the de facto kind of interface language, right? You build your smart contract in Rust, and then you build your client in TypeScript, and that could be a web app, or a server. But the majority, people are building React web apps, which I'll be honest with you, I'm not really big into front end development. But that don't mean we won't do it if we don't have to. If we have to. So let me paste a link to where we are starting off here in the chat. We're picking back up on the Rust book. I hope the people that are watching out here have not been waiting for me to make another video to learn more about Rust. I hope you've been out there writing Rust. And I think so. Let me just bring up the Rust book real quick here. We've gotten some good stuff in here. I think what my plan is going to be is to get through section 4, or chapter 4, I guess we would call it, understanding ownership. That's going to be the next video. It's a big one, right? People struggle with ownership and borrowing, the borrow checker in Rust. I think we're going to get through that, and then we're going to come up with a cool app to build together. And I really want to see other people's apps. So make sure if you're learning from this, come mint a groms.club, join the Discord server. You'll see all links on the website, Discord, Twitter. Follow us and come and learn. It's been a little quiet because I think partially it's because I've been busy, But I'm still dumping all my like things I come across when I have spare time in there. And I think it's really interesting. There's so much going on in the Solana ecosystem. I think the other thing that's happened, a lot of people that have been learning with us have been going on to build things, and so they're there and they're helping each other and answering questions, but there's not as many new people in there answering questions, and that's all on me. So we're gonna get back to learning Rust, and we're gonna get back to learning Solana programming, and yeah, we're gonna learn together. So come join the Groms Club. Most of the good stuff you need to have a Grom. I'm just gonna be straight with you, right? You need to be a part of our community. Buy a Grom. It's half a soul on a half one soul token, so it's not too bad for the value. Like this is the if you want to become a Solana programmer, it's one of the most valuable programming skills, right? Like you get paid one of the highest salaries, probably only second to being like a Solidity developer, and who knows, maybe someday that'll change. Or for the time being, like if you want to be ahead of the curve, this is the place to be, right? So my plan is to keep learning Rust. We're gonna do some. We're gonna finish the raw Solana programming series, and we're gonna dive into Anchor. And like I said, we may like squeeze in some TypeScript, because I know like TypeScript's a little easier to approach. Well, JavaScript and then TypeScript. Yeah, so that's my plan. Anyways, let's get started. This is like some of this is gonna be pretty simple if you're an experienced developer. Let me shape this up a bit, because I know this isn't the best way to view things. So comments are really simple. We got an error. What's the problem? Oh, I don't know. What is that? Looks like I just sat on the keyboard. All right. Okay. So we're just gonna take a brief minute to talk about comments, okay? Because there's not a lot here, right? Comments are they're just comments, right? They don't mean anything, and they actually get a little more involved than what we're gonna see in this section. You have I think they're called doc type comments or something like that will actually publish to the documentation of whatever it is you're writing. So like if you're writing a package or something, or a crate, we should say, it will associate, like that function will have documentation for it. So that's really cool. But we're not going to go into that today. We're just going to stick to the book, the Rust book, and we're going to, this is really simple. I'm not going to spend any more time on it. We'll just do this, right? This is a comment. This is another comment. Let's do this. This is a comment. This is a multi-line comment. It's really simple. Comments. Remember, we went through the whole compilation process. I honestly don't. During the compilation, because we have the compilation process and the execution process, right? That we talked about a good amount. I'm not sure precisely what happens to comments in the compilation process. I would assume that they just get ignored by the compiler and not included in the binaries, but I could be wrong. What I do know is that they're not going to affect the function of your program when it's compiled and running. So this is the purpose of comments. I'm not going to go deep into it because there's a lot of different kind of philosophies around the way comments should be used. But these comments are just like information that may not be immediately apparent in the code. Sometimes, if you're working on a program that's just for you, you'll leave a comment for yourself to kind of help you remember what this is for and why you put it there. If you're working in a team, that becomes more important. Understand, in case you are not around or no longer working on that, or just too busy, you want people that you work with to be able to come in and read your code and understand what it means without having to spend a lot of time. There's a lot of different philosophies on the way comments should be used. Some people say that ideally the code speaks for itself and that you don't have to write comments. I don't know if there's a lot of people, but that's one school of thought, right? That if there's a comment, then that means one school of thought is that if there's a comment, that means that the code is not written the way it should be. But I personally, my experience, every tech company I've worked for, and that means I guess it's about 5 or 6, has comments. So I think those people are rather few and far between. So use comments for your code to help you remember things. I'm not particularly I don't consider myself well versed at comments. I just use them when there's like little gotchas that like, hey, this is something that this is why I'm doing this. Like maybe there's some weird corner case or there's some kink in the design of the system that I'm building on that I need to leave a comment just in case something looks like way out of place. But that's it. It's important to know if you're learning to program for the first time, reading comments is really important. And that's why I'm kind of for them, because at the very least they help people who don't have the context to read your code and learn from it and then build on it if necessary, if that makes sense. All right, control flow. I know it's not very big. I'll make it a little bigger. Let me get this guy out here. So control flow, if you've ever programmed before, you've probably come across the ideas of control flow. Hang on a second. All right, there we go. So control flow is simply like an if statement, and I suppose a for statement, right? Yeah, if the for. Do we include for statements in control flow? Yeah, we do. Okay. Yeah, so there's a lot here, a lot of different ways. If is like, your kind of standard logic gate, if that makes sense. Sorry, I got distracted here. I'm just getting my. I have to apologize again. I'm still getting back in the groove. All right. So this wants us to create a new project. I'm not going to do that. I'll just use our hello world, but it doesn't really matter, right? We know how to run and build. That's still not the biggest, huh? Right. It's a little more readable, I think. So the if statement is really just like logic, right? If this happens to equal, or if this happens to be true, then this happens. With else, then something else happens. So let's write this up. I'm gonna just remove all this. Work here. So like, what do they have? They have like a really simple, let number equal 3 if number is less than, what did they say, 5? Doesn't matter. Okay. Or that's less than, huh? Number is less than 5. So they said something different. Say condition was true, else print condition was false. Give me just a moment here. Apologies, I had to clear my throat. All right. Else number is 5 or greater. And this is not going to do us very much here. We need to do our print line macro. Sorry. I'm so discombobulated. My desk is a mess right now, so apologies. I'm moving things around as I'm streaming, which is incredibly unprofessional. But who said we're professional here? Um, all right, let's hide this for now. We don't need different files for now. So let's just run through this again line by line since we're rusty and getting back into it. This simply assigns this value to this number. The Rust analyzer is inferring that this is an I32, which is the default integer type that it's using, which is a sign integer. So that number could be a positive or a negative number. And then this logic here is evaluating that number against the number 5 and is determining if it is less than 5. And so what happens is this is essentially, you can think of this like a little function that returns either true or false. What happens here after the if statement. And then depending on the output of that statement, you'll have 2 branching pairs of logic, or you have 2 potential branches of logic. If number is less than 5, then we're going to print the number is less than 5. So if this equals true, whatever happens here is going to be true. And let's just to be clear about something here. Just get rid of this. You don't need an else statement. If we run this right now, let's just go ahead and run it using our IDE helper. It's compiling and running. So this is the only output we need to worry about here for the time being. This number is less than 5. Let me just bring this up a little bit. So now let's implement our else statement. Number is greater equal to 5. Period here just to satisfy my grammatical what's the word? My grammatical aesthetics. All right. So what we've done is we've added this else statement, and all that does is give us something to happen if the if statement, this number is less than 5, is false. And actually, I'm going to remove this again because I want to make something clear before we add that else statement. So, and this is real basic, right? And it's okay. Let me be clear when I say that. It's okay if you don't know this. That's why we're here. But if you're advanced, if you're an experienced programmer, this is probably like all pretty second nature to you, right? So we're going to put this number as 5. And so now that we have this if statement, we don't have an else. And so what that means is we've accounted for the situation where this if statement is true. But when it's false, what happens? Well, the answer, I'm sure it's obvious, is nothing, right? Because we haven't told our application to do anything. And so where we previously saw that line of output that said the number is less than 5, we now see nothing. The program compiles. Remember, this is all using cargo for us, or cargo scripts. It compiles a program and then runs a program. And what happens when it runs it is not this computation happens, right? This gets assigned, 5 gets assigned to the number variable. It evaluates the statement. Is the number less than 5? It's our statement here. I feel like I just lost audio or something. No, maybe not. Right. I see there's 2 people watching. If I have any audio problems, please let me know, because I just heard like a noise in my headphones that my audio is failing. Might be my battery going down. So I may have to cut this short. But for the time being, let's trudge on. So as I was saying, in the event that this is false, we don't tell our program to do anything. So that's why nothing happens when the number is 5. It would do the same thing if the number was 6, because the number happens to equal 5, which we've only accounted for numbers less than 5. And we'll do this, right? This is getting a little explicit, right? Like we're some of this is probably pretty straightforward when you read it, but I think it's good to understand this as we move into some of the other control flow available. So now we have this else statement that accounts for the state in which this statement evaluates to false. What you can think of here is like true, this thing happens. If false, this thing happens. Let's run it again. We'll get our debug and see. Now we have this output that we expected. The number is equal to or greater than 5. Cool. And then let's just for posterity's sake, we'll run this with a couple different numbers. We'll do a 6, which is in fact greater than 5. We should see the same, right? The number is equal to or greater than 5. And then we have, we can do 3 like when we started. We run it. What do we get? The number is less than 5. Great. So everything's working the way we would expect. Okay. I hope that's pretty straightforward. If there's any questions in the viewers, please don't hesitate to ask. All right, we kind of did all this, right? Yeah, so this like just letting us know that there has to, like, whatever comes right after the if statement has to be has to return a Boolean of some sort. See this bool, and a Boolean is just a true or false operator. If we were to just say the number, what that statement becomes is just like an integer. Problem here. See, mismatch expected bool found integer. All right. And so we have a number of different operators here. Let's just go through kind of some variations here. So now we're saying less than or equal to 5. And I'm not going to change my print line statements just so we can say what happens, right? So this number is equal to or 5, less than or equal to 5, right? And we've actually set it to 5. And so this is just to illustrate. This still says the number is less than 5. Your program is going to run whatever's in here because it's listening to you. So if you write something that doesn't align with the output of this if statement, you could, this could be incorrect. So this is clearly incorrect, right? Because we've entered 5. This is evaluating to determine if the number is equal to or less than 5. And that's why the output doesn't match the logic of this statement. So how do we change that? It's pretty simple. We just use this number is less than or equal. And now we need to update this one to this number is greater than 5. Right? Because that's what is on the other side of this, right? If it's not less than or equal to 5, the only option is for, if we're following standard arithmetic, the only option is for this to be greater than 5. Let me just make sure I saved. And run again. Number's less than or equal to 5. Let's bump it up to 6. Run. Number's greater than 5. All right, a couple other situations. Just to be clear, no correlation with what comes out here and the the actual statement that's evaluated. Cool, right? We can just do that. Foo. I'm curious. I don't think that'll work, right? That's going to give me an error, or is that considered a, no? Okay, so it doesn't give me an error there. So I guess since this is like considered a return, or the last statement of this logic, it's not required. I'm not sure about that. That's interesting. I expected that semicolon to be required, but it's not. Anyways, that's not important right now. Yeah, so let's try some other states here. Let's hello. And now we have a problem because it's trying to like these operators or comparison. I think they're called comparison operators. Require that this be an actual like number of some kind, or that these variables are the same type, so they can actually, or at least comparable. And since these variable types, this number is now a string slice, right? I forget what we call them. And this 5 is an integer. It's having a problem with that. Now we're good again. Okay. So we can do a number of different if statements, right? In that case, I'm going to use kind of my own options here instead of theirs. They're using dividers to, or the modulus operator. Just to keep it simple, I'm going to use some of our straightforward less than, greater than, equal to logic. So if number equals 6, so we don't need that. Now we've created a special condition just for the time when the number actually equals the 6, right? We don't actually want else here. We want else if. That's a else if number is less than 6. We could also do, let's do this, else if number is greater than 6. Oh, can't type. I'm rusty. So we'll run that. Number 6. Okay, great. Well, what's less than 6? 5 is less than 6, isn't it? And less than 6. Okay. And now 7. Okay. So one thing to keep in mind here is we don't necessarily need this comparison. What we can use is just another else statement at the end, and it's pretty typical. You'll see this else statement here at the end. That this number could be. Knowing this is an integer. All right, so we know. So at this point, let's just walk through this. Right, the number is 7. So when we come here, when our program running comes here, it's going to evaluate the statement, and this says the number if number equals 6. No, it's false, right? Okay, great. So we're not going to print this. We're going to move on to this next line. We're going to skip these brackets. Else if number is less than 6. Well, hold on. Before we do that, let's say, so if the number does not equal 6, which we determine here, then that means the number, for it to be a number, it can be one of two things. It can be either less than 6 or it can be greater than 6. Like we can encompass all options within by saying those two statements, right? So we know that the number is not equal 6. The number will be either less than 6 or greater than 6. All right, so let's check to see if the number is greater than 6. So in this case, it's not, right? It's 7. So this is false. So now we've eliminated another option, right? The number can only now be greater than 6 for this number to exist, right? So we've gone through this tree of logic you can think of with the different branches, and we determined that the number is not 6. The number is not less than 6. So anything else in the world that's a number, it has to be greater than 6. So we don't need to put a comparison operator here. Now you can if you want. It doesn't hurt anything. But this else becomes like a catch-all. Okay. So anything that doesn't meet these two conditions above it, this else will then what's the word? Will then execute this line of code. Now, if you see here, they have two else ifs. That's fine. These can go on indefinitely. Like you can bang a bunch of them. They're not necessarily like, so somebody might recommend putting this in just because it makes the code, arguably it makes the code more readable. I don't know. Maybe it does, maybe it doesn't. That's a kind of more opinion thing. But, if you don't care, like, and you just want this to run, if the above two options are not true, then just put else. So, like, going back to kind of our else statement, or just our straight original kind of else. If the number equals 6, that's not true, then what can we say that's true in English? The number is not 6, right? We can't say the number is less than 6. We can't say the number is greater than 6 because we don't know. Okay. Let's add another operator here. Remember we did the less than equal to earlier. Another operator to be aware of here is this, what do they call these? I don't know, they're called interrobangs. I just call them exclamation points when talking, right? Because I guess the not operator, maybe that's true. So what this is saying is the number is not equal to 6, print line the number 6. So this is like, we need to change this. But just to be clear before we change that, just know that this exclamation point here, in this context means not. So like you could do, how does this go? Not, I think that's how you write not less than, right? Sorry. So that's like not less than, greater than, and equal to. All right. So let's make this true. Like let's make the logic of this statement equal the output is not 6. We can say with confidence, due to the output of this Boolean statement, the number is not 6, print line the number is not 6, right? And the number is 7, so it should say the number is not 6. And what's going to happen if we, just to review while we're here, the number is 6, what's going to happen? Nothing, right? Because we don't have anything. We don't have anything, any logic for when that happens. Now we have logic, right? The number is 6. Okay. All right. So using if and a let statement. So this is interesting. This is I don't know how widespread this feature is of language. What you have here is kind of like a condensed assignment and control flow statement. So what you're doing is, well, let's just copy their code just to make things simple. Oh, we can run it here, huh? So let's just walk through the book here. Make sure it's nice and readable. Yeah, it looks pretty good. So when this statement or when this function runs, the main function, we're setting this condition variable to true as a Boolean. And now this is where it gets fun, right? This is where we're introducing this if statement with let. So remember, going back to some of our previous streams, this variable assignment started with this let statement. And remember, we have other keywords that can be here, but for the time being, we're keeping it simple. And what's happening is this is like if you can see it, this is really. Let me just actually write this out because it'll be kind of, I think, more obvious. We need to set this Boolean variable. I'm really struggling with typing with this microphone in my face, so apologies. Let's blow this out a little bit, huh? So this looks a little familiar, right? It looks a little bit more like our if statements we've been using. Let number equal. I'll kind of read this in English the way it kind of reads. Let number equal 5 if this condition is true. I guess a better way to say, if the condition is true, it's returning this 5, and this 5 is then getting assigned to the number. Else, so this condition would be false, right? Because a Boolean can only be true or false. Else returns 6, and this number equals 6. And since our condition is set to true, what do we expect our number to be? 5, right? So if this is true, the number equal 5. Well, let's, I don't know. Let's do if 1 is less than 2. I'm not even sure if it'll let us do this, but we're going to try it. I don't see why not. On your condition there, because it's just doing nothing. So if 1 is less than 2, which it is, return 5. Now, if 1 equals 2, return 5. Else, if 1 does not equal 2, return 6. What's going to happen? 6. All right. So this is cool. Like, you can just kind of combine these steps, right? Instead of like having to. I guess here's another way you could do this same thing. If 1 equals 2, and right, not a useful comparison, but we're using it for now. Let number equal 5. Sorry. So we have some problems here. Let me just do this. this probably for some. Oh yeah, so we lose the scope in this, so we can't really do that anyway. But that's fine. I really just wanted to kind of illustrate the fact that this is essentially what we're seeing, right? It makes this like a little easier for us to read, I think, once you get used to it. Not so much this way blown out, but in the way it's written here. It's much more concise, makes sense. Yeah. So this is something to be aware of when we try to compile this code. So here they have a string in the or stir rather. Sorry. In the second in the else branch. That's a good. So let's use the term branch, right? This is a branch and this is a branch. There's this if branch and there's an else branch. You know, and then up here there's an else if branch, else if number, branch. These are all different branches. That'll is a good way to refer to those. Sorry, I lost our place. So this will go back to some of our compile time stuff, right? To be aware of. This expected integer and I found a string. So these need to be the same type. Now, why? Or they need to be at least compatible. Why is that? Well, one thing that we need to know at compile time, and that's when the compiler comes in and compiles our code, it needs to know what type this variable is going to be. That way, it can save they can allocate the memory space for it, because an integer like the number 5 takes up a lot less memory than stir. Okay. In our next stream, we're gonna probably our next stream, maybe not. In one of the very soon streams, we're going to talk about memory. I've been spending some time learning about it so I can explain it better. So I'm really looking forward to that. But yeah, that's coming up. But just know that this is why it's not letting us do this. It's not letting us have two different types in this if statement. It needs to, whatever we're assigning to this variable, they need to be of the same types. Or compatible types, I should say. I think this will become more apparent what this means later. But let's just say compatible types. So likely, this is my speculation, is that likely these need to have like they need to be able, they essentially contain in the same like memory space. All right. All right, so now we have loops, right? So these are a little more complicated than if else. The if else in general on their own. I have this. I must have done something to bring this in. Stop. So in general, our if else statements are kind of one shot, right? They just kind of evaluate and move on and do whatever you tell them to do, unless you have them in a function and are calling them multiple times. They're just kind of one shot. Now we get to have some fun with loops, and these loops are kind of like where things really kind of get fun, because we're just kind of doing things over and over, and we don't have to do them manually, right? This is a really cool feature of Rust, I think. It's called the infinite loop. I don't know if it's what they call it. I was gonna call it infinite loop. It's really easy, and we're actually going to create an infinite loop with it. It's just a loop, I guess they call them. But it's kind of cool because this is a really simple way to just like get something moving, and then you can stop it manually. We're going to stop it manually in the command line, but in your code, you can kind of set up conditions for it to stop. So this is just running indefinitely right here. This, like, it looks like it's staying still, but this is actually just going again and again and again. See, if I scroll up, it's just not stop. So let me just stop this. Yeah, okay. Yeah. So yeah, it's just running and running and running. All right. Oh, I don't need all that. We don't need our terminal for now. Okay, so so when I was stopping that, I was hitting Control C to stop it. But ideally, what you want to do in your loop is stop it like after a certain condition, right? So let's just do something. I'm gonna do something really simple here. I'm gonna make it mutable so we can change it. And then let's do let's do this first. If count. All right. So what I'm doing here is I have this using this break statement to kind of manually stop the loop. Essentially, you can see. So this loop. So let's just run through what's gonna happen. We may need to stop here. I'm running short on time. This took longer than I expected, and that's okay. I'm hoping to get back in the swing of things, and I'm really enjoying this. So here's what happens. We assign the count 0 to this integer, and we put this MUT just a refresher, so it's mutable, and we can change the number. If I didn't have this, we'd have a problem adding 1 to this number. So this loop kicks off. It first checks using our if statement. If count is greater than 10, break. Now, so theoretically, I could put an else statement here and then do this, right? But I really don't need to because I don't need, we know this is just going to run afterwards. And so break just means stop the loop, breaks loop, exit early from a loop. When break is encountered, execution of the associated loop body is immediately terminated. So we're going to print line. So if the count is not greater than 10, so it's 10 or less, we're going to print this count statement where it prints count and then has count afterwards. Then we're going to add 1 to count just so this doesn't keep on going, right? So what should we see? Here's what I think we should see. We should see 0 printed out here, and then it's going to add it to 1. It's going to come back through this loop, hit this again, check 2. It's going to keep doing that until this says 10. It's going to at some point this is going to equal 10. Count is going to equal 10, and then it's going to add another 1. It's going to equal 11. So then when it comes back to this loop, it hits the if count greater than 10, and it's going to break or stop, and then this whole program's done because we don't have anything else going on after the loop. Yep, and that's what we see. Look, 0, 1, 2, 3, 4. See, so pretty simple, right? This loop's pretty powerful. It's pretty cool. This is cool. This loop label. I don't remember. I don't know honestly if there's a new feature. But yeah, you can label the loop so it's like you can be specific about which loop you want to break. So in this case, they have like multiple loops going on. They have a loop and there's nested loop. And then there's different conditions. It'll break either the loop it's in or this counting up loop, which is cool. Let's run it. I want to see it. Yeah, so that's cool. So similar, and I'm moving a little fast here just because I need to wrap up for the day. But thanks for everyone for watching. Let me just scroll ahead real quick. Yeah. Okay. Anyway, I don't know. Yeah, there's parts in here that I think you can learn on your own. Like you should just go learn on your own because it's simple. It's similar enough to what we've been doing. So I may, because I really want to get into memory, and I think that's like a big challenge for a lot of people when they're learning Rust. All right, so this is really similar to what we did with our if statement, adding the let statement. It's just the result of this this loop statement is assigned to this result variable. So let's run it. So after the loop, we use a semicolon to end the statement that assigns a value to result. Right? So this counter times 2 breaks, and that's what gets dumped into the result variable. All right. Oh, sorry about that. So while like this is similar to the loop statement, it runs until this condition is no longer true. So it's similar to loop. In loop, we need to be explicit within the loop of what conditions are going to break it, or using the break label, the labeled loop. With the while statement, we set the condition of what, like, of a condition for it to keep running, essentially. So whenever this statement here becomes false, then the loop will stop. This while loop will stop. We can run that just for posterity's sake. 3, 2, 1 left off. All right, so this number starts at 3. So while this number is not 0, not equal to 0, we're going to print line the number. So we're going to print 3 minus 1. So now the number is 2. Comes back here. While number is not 0. Okay, number is still not 0. So we're going to print again. It's 2. Number minus 1. So now the number is 1. Number is still not 1. Print the number. Okay, great. Now the number is 0 because this number subtracts another 1. So when this comes through, it says, oh, this number now is 0. So this statement is no longer true. So let's just stop doing whatever's in here and go to print line liftoff. Okay, pretty straightforward. So for loops, man, I wish I had time to go through for loops. I'm gonna encourage you to go through for loops. So like, if you've programmed before, for loops are pretty straightforward. There's some syntax that kind of actually makes things a little better for you that you'll learn along the way with Rust, but I'll just walk through this real quick. So this is really cool. I think other languages have this, but it was new to me when I saw it, when I first started getting into Rust. For element in A, print line, this value is. And so what this does is actually just when this A, this variable A, so in this case it's an array of numbers, it just makes it easy to iterate through these numbers. So for element in A, what that means is for every so element's a keyword, a variable, not a keyword. So just to be clear, like this could say junk. For junk in A, print line junk, and then it would still do the same thing. What it's doing is for this, it just substitute this variable for every piece of the array. So for element in A, the array A, run this statement and use this element keyword. And so what's going to do is for element in A, so let's say 10, it's going to say for 10 in A, print line the value is element, which is 10. 20, for 20 in A, print line the value is 20. And it does that all the way through. So we should just see the value is 10, the value is 20, the value is 30 through the whole array. And it's taking a while to run. I don't know why. It timed out. If it just has a problem, we'll just dump this into the IDE and run it. All right, there's probably something going on. Let's just get this out of here. Oops. All right. So let's just run this. Yeah, so that's what we expect, right? All right, moving quickly. I think. Oh yeah, so this is another like kind of cool little feature of Rust in this this range, or they're called. You have these reverse operators, so that's cool. What's awesome about this is when it's working, you can just run this. Bet if I reload my page, oh yeah, it worked that time. So what does this do? This range. So this is like just defined in this line of code. This 1 through 4. This telling Rust for the numbers 1 through 4. For numbers 1 through 4, do this and then reverse them. Print these numbers. So what it's actually doing is going print line 4, print line 3, print line 2, print line 1, and this can be 1 through 20 or whatever, and then print lines left off. All right, cool. So we're done. I'm gonna encourage you. So here's some good like exercises. Maybe next, maybe next stream we'll go through these together. So your homework, if you're watching this in the stream or in the YouTube video, is to go to this page and do these assignments. And you can, if you're in Grom's Club, come share your work. So I'd love to see them. If you're having problems in your Grom's Club, get a Grom. Come talk about your problems, your Rust problems specifically. I don't know if I can help you with other problems. Try these out. Maybe we'll go through these in our next stream. Maybe I'll do like a quick stream if I can squeeze it out, and we just work through these one or 3 of these. Cool. All right, it's been fun. Go into groms.club. We got the links in the chat, but it's really simple. Groms.club. Keep on in Rust. Keep grinding. Don't wait for me. I'm gonna keep doing streams, but don't wait for me. Keep working. All right, y'all. Be good. Carry on. Live your life. Learn Rust. Talk soon. Peace out.